In this video, we're going to discuss the sum and difference of cubes. So to factor those expressions, such as a cubed plus b cubed or a cubed minus b cubed, you need to learn the following formulas and how to use them. The sum of cubes formula is, given a cubed plus b cubed, it factors into a binomial of a plus b times, in parentheses, a trinomial of a squared minus ab plus b squared. Difference of cubes is a cubed minus b cubed, and it factors into a binomial of a minus b and a trinomial of a squared plus ab plus b squared. Notice how the pattern in the parentheses is the same except for the signs. And this is the best way I've found to learn this. First, I want to memorize the right side in terms of the variables and the letters. So basically, what we see here is that the a and the b, that is here in this parenthesis, come from taking the cube root of this first term a gives me a, cube root of b cubed gives me b. Using those two variables, I can do the second parenthesis, which is always going to be the square of the first number, first cube root, minus the product of the two cube roots, plus the square of the second cube root. Notice that in the sum of cubes, the first binomial matches. It has a plus sign in the original expression, has a plus sign in the binomial. The next open space to put a sign in is after a squared. That one needs to be a minus. Each of these formulas only gets to contain one minus sign. Now looking at the difference of cubes, a cubed minus b cubed. So again, we start by taking the cube root of a cubed, which is a, and the cube root of b cubed, which is b. So the first binomial of a difference of cubes is a minus b. So its sign is going to match the original problem. Now since I just said you can only have one minus sign in the formula, that leaves no other spots in the formula can I put a minus sign. So the rest must also be positive. Now how do I know that it's going to be a minus here? Well, I basically tell myself it goes in order. Here's my first opening for a sign. The second opening is here between a squared minus ab. So if I don't use it in the first opening, I have to immediately use it in the next opening. And now I'm done using it. Other thing to keep in mind is the b squared, if you have a cube root, and that number happens to be a negative, because you could say the cube root of negative 8 is negative 2, anytime you square a negative number, it's going to be a positive. So the last term has to be positive. So you need to process the formulas in such a way that will help you memorize them. Let's do an example. Factor the following. So what I'm going to do is I'm going to start with step 1, which is to calculate the cube root of each term. So the first one here, 8a cubed, the cube root of 8 is 2. The cube root of a cubed is a. Then I go to the last term. The cube root of 27 is 3. Now I have everything I know to plug into the formula. Since it's a sum of cubes, my first binomial is simply going to be an addition problem of 2a plus 3. Now the last part, a trinomial, starts with taking the first term and squaring it. So 2a squared is 4a squared. The middle term we said would be a minus, and all we do is take the product of the two cube roots. So the product of 3 and 2a, or 6a. And the last term will be plus, and it will be the square of the 3. So that would be 9. That is as far as you can go. This trinomial is not factorable. So that is the end of factoring the trinomial. Let's try another one. Now this one, you'll notice that the 2 and the 16 are not perfect cubes. So even though it looks like sum of cubes because there's an x cubed, I'm going to have to do something first. So I notice that 2 is the greatest common factor between 2 and 16. So I'm going to factor out the 2 first, and that's going to leave me with x cubed plus 8. Now this is definitely a sum of cubes. So now I'm going to take the sum of cubes, take the cube root of the first term, which in this case is just x, and the cube root of 8 is 2. Now I'm going to plug them into the formula. Since it's the sum of cubes, I'm going to put in the first term plus the second term. Now the rest of this formula is simply the first term x squared minus the 2 multiplied together, 2x, plus the last term squared, plus 4. Now I did factor out a GCF in the front, so I need to put that in there. So now this is my entire answer, because if I multiplied it together, it would come out to be 2x cubed plus 16. Now I'm going to have you try 2 of them. Notice that the bottom one here in the samples is a subtraction. See if you can remember where that 1 minus sign is going to go. Pause the video, try the problems yourself, then resume the video to compare your solutions to mine. Taking a look at the first example, I'm going to start by noticing that both 64 and 8 are perfect cubes. And x cubed and y cubed, of course, are perfect cubes. So I'm going to take the cube root of 64, which is 4, cube root of x cubed, which is x. And then I'm going to bring down 8, so the cube root of 8 is 2, and the cube root of y is y. So I have the numbers I need to fill in the formula. Since it's sum of cubes, the first binomial is going to simply be 4x plus 2y. The trinomial will be the first term squared, so 4x squared is 16x squared. I need that 1 minus sign, so it has to come next. The middle term is simply multiplying the 2 terms together, 4x and 2y. So 4 times 2 is 8, x times y is xy. Last term always has to be positive because I'm squaring. So if I square 2 and y, I'm going to get 4y squared. Now, this particular problem, you may have noticed that although they were both perfect cubes, I could have gone ahead and factored out an 8 and made this a little bit smaller. Because what do you notice here in this example? I happen to have a greatest common factor in this first term. So let's see what happens if I factor out the 2 there. So now I have 2 times 2x plus y. And if I factored out something in the other one, I'd be factoring out a 4 and be left with 4x squared minus 2xy plus y squared, which would equal 8 times, oops, let's put that down below, 8 times 2x plus y times 4x squared minus 2xy plus y squared. So one thing to keep in mind with this example that I want to show you is if you don't see a greatest common factor first, but you can go ahead and start to factor something correctly since these are both perfect cubes, you can do that, and then at the end just take a look at your answer and see that, oh, wait a minute, there's a greatest common factor there, and go ahead and continue factoring them out. So doing them that way is the same way. But just to show you, if I had factored out the 8 from the first term, I'll put it up here. If I'd factored out an 8, I would have been left with 8x cubed plus y cubed, and would eventually get to the same answer. So my emphasis on that is a lot of times students will not get the greatest common factor first, but as long as you check your answer and take it out at the end, you'll still be okay. Okay, now let's take the next one. Now this one I put in a subtraction to see if you could remember the formula for the difference of cubes. So in this case, I have 125a cubed minus b cubed. So 125, the cube root of that is 5. And of course, a is the cube root of a cubed, and b is the cube root of b cubed. So now I'm going to put the binomial first. Since it's a difference of cubes, the binomial needs to be a minus sign. Has to be difference. From here on out, everything will be positive. So the first term is 5a when you square it, which is 25a squared. Second term, you multiply them together, 5a times b, or 5ab. Plus the last term squared, which is b, which is squared as b squared. And there is my final answer.